Alright, here is part 2 of the video guide for lesson 10.1.2. In the first part we did the problem I love, the Eratosthenes problem, and then I left off after part A, where we introduced the idea that the measure of an arc could also be talked about in degrees, and if you're talking about the measure of an arc in degrees, it's the same as your central angle, and we're talking about a circle that's made up of 360 degrees. So if your central angle is 40, the minor arc across from it's 40, and then the major arc is whatever's left, and that's why in this problem I actually did do, sorry, my computer's acting up there, 360 minus the minor arc gave me that major arc. Part B, we're just going to kind of convert this. We're going to convert it to like what we saw in problem 1, where we have feet and different kind of measurements. So let's read this here. When Eratosthenes measured the distance from Syene to Alexander, he measured the length of an arc, that distance called arc length, we've seen that, and it was measured in centimeters or feet, and I think in his case it was miles. One way to find arc length is to wrap a string about a part of a circle and then to straighten that string out and measure it. We're not going to do that here, but that's just a strategy they've talked about. Now, what it's telling us to do is we want to calculate the arc length of that minor arc, SU. So the one that we said was 40 degrees if we called it a measure in degrees. We're going to try to find out what that length would be. And I don't know, do they get, in inches here, because they're telling me the radius of circle T is 12. And so we know the radius is 12. Let's figure out, well, what would that arc length be? And we've done problems like this before. So if we want to find an arc length, what we want to do is we want to find the circumference of the entire circle and then multiply it by the portion of the circle that we want. And so to find out circumference is always 2 times pi times radius. And in our case, that is 2 times pi times 12, which gives me a circumference of 24 pi. All right, now that 24 pi is my entire circumference, but I don't want my entire circumference. I just want this little slice right here. And that little slice right there is 40 out of 360, and that's the portion I'm going to use. So I'm going to take my entire circumference, 24 pi, and I'm going to multiply it by my portion, 40 out of 360. And I actually could reduce that down. I could make this 24 pi and multiply it by 1/9. It's the same fraction, just reduced. And then when I multiply this here, I actually just do it in my calculator. And I put in my calculator 24 pi, and I put that in parentheses, and then I multiply it by 1 divided by 9 in parentheses, and it gives me an answer here, an arc length, and I'm going to call that AL. I don't really know if that's appropriate for, I don't think that's how like people usually write it, but that's what I'm going to do for shorthand here. And I'm going to say that that arc length is 8.38 inches. And that is the answer for B, I believe. We had the whole circumference, multiplied it by the portion, and figured out what it was. On to the next problem and the one after that. They're both somewhat quick. For this problem here, 10-15, this is one that I really just want you to pay attention to and jot down my answers to, because really the idea, and I'll read the problem because there's some good vocab in here, but really the idea is to use tracing paper to reassure us on these ideas. But we don't have that, so you're just going to have to trust me and use the information that I tell you here, and we'll use that information on the next problem. And so I'm going to, like I said, I'm going to read it because I think there's some good vocab in here. In the diagram at the right, angle BDC, angle B to D to C, is an example of an inscribed angle because it lies within circle A and its vertex lies on the circle. So what they're saying is that its vertex is on the circle, D is on the circle, and the rest of it lies inside. So it's an inscribed angle inside that circle. It corresponds to the central angle BAC because they both intercept at this on the same arc. So what they're saying is B and C, like A, that central angle, makes up B and C, and so does D. D makes up B and C as well. And so there's just these two different names. An intercepted arc is an arc with endpoints on each of the angles. So we have our intercepted arc, and we have our inscribed angle, and we have our central angle. And so those are the three big things right there. Intercepted arc because it's made up of both central angle and inscribed angle. And then you have central angle in there as well. Okay, investigate the measure of the inscribed angles as you answer the questions below. And so we won't actually be able to put number values on this, but we just want to look at this relationship. And this is where you just got to trust me, because this information I'm going to say is true. And we could see it, or you could look it up or whatever. You could use tracing paper if you have it to really check this. But it says in the circle at the right, angle F, angle G, angle D. So F is blue, G is red, H is green are examples of inscribed angles. All right, because their vertex is on the circle and they're making up some part of the arc. Notice that all three angles intercept the same arc, JK. Now we want to use tracing paper here to look at angles F, angles G, and angles H. And what do you notice? Well, what we hope to notice if we did this was that angle F, angle G, and angle H are all the same. Or another way to say it, you could say that they're all congruent, but I'll say all the same. Okay? And really what's happening there is that because these are all inscribed angles and they're all creating the same arc here, that must mean that they're all congruent, because otherwise they would create a different arc. They would create a bigger arc if it was bigger, or they'd create a smaller arc if it was smaller. So since that it's creating this arc JK, they all are, that these inscribed angles must all be the same or congruent. Okay? And then that brings into part B here. Okay? And it says, now compare the measurements of the central angle, so WZY, that central angle, and the inscribed angle WXY. What is the relationship of the inscribed and the corresponding central angle? And this one here is that the inscribed angle, and my handwriting's terrible when I actually have to spell words. My inscribed angle is half the size of my central angle. Two really big things here. All right, and so like just to kind of make sense of B a little bit more, what that's saying is like if you called angle WZY, that central angle, if you said that was 60, that means WXY would have to be 30, because it's half the size of it. It's half the size. Half the size of it. I was thinking of a better way to say it. I couldn't really do it. All right, and so the two big things to take away that we're going to apply in the next problem is that if you have inscribed angles that are all creating the same arc, all those inscribed angles are congruent. And if you have an inscribed angle and a central angle creating the same arc, your inscribed angle is half the size of your central angle, or if you think of it another way, your central angle is 2 times bigger than your inscribed angle. And we'll use that in the next problem. All right. In problem 10-15, you found out these measures of the inscribed angles. I don't really have to read this one. And really, I think on our worksheet, I cut out D, E, and F. And we're just going to do A, B, and C to practice it a little bit here. So in problem 10-14, we said that the central angle is always the same as the angle on the outside here, if that's the way we're looking at it. So if I had and I can't really draw it all that well, but if I had my central angle in here, the central angle would be 118 because the outside, that arc measure, is 118, and that's what we saw here. The central angle was 40, and so the outside was 40, and we're going to use that. And so what we just said in the last problem was that, or sorry, in 10-14, we said that that would have to be 118 because the central angle is the same as the measure on the outside. And what we said in the last problem was that the inscribed angle down here is always half of the central angle. So if I'm looking for x, that inscribed angle, what I have to do is cut 118 in half. And so for part A, I have to do 118. I have to divide it by 2. And I should be able to do this in my head, but I don't think I can. I believe this is 59 degrees. I'm going to write it and then I'm going to check it. So 118 divided by 2, yeah, 59. All right. And so again, I know that because again, my central angle is the same as my measure on the outside, and then my inscribed angle is half of my central angle. So that's why I decided to cut that 118 in half. All right. B is kind of similar, just working the other way. You're given an inscribed angle is 41. Well, that means the central angle would be 2 times as big, and that central angle is the same thing as the measure on the outside. And so what we're going to do, instead of dividing it in half, we're actually going to multiply it by 2 for B. So for part B, we're going to take that 41. We're going to take that 41. We're going to multiply it by 2, and we're going to get 82 degrees as our answer. That 82 would be the central angle, and that central angle is the same as the measure on the outside. All right, last one here for us, because I cut out these other ones. Part C. We're given a lot of information here. We have to find x, y, and z in this problem. And it's really not too bad. It actually hopefully will add up to 360 degrees for us. But really what we're doing here is we are going to do the same thing we did in part B, but we're going to do it 3 different times. So for x, our inscribed angle for x is 90 degrees, which means the central angle is 2 times bigger, and that central angle is the same thing as x. And so for x, I'm going to take that 90 degrees, I'm going to multiply it by 2, and I'm going to say x equals 180 degrees. Like I said, hopefully because we have all 3 parts, x, y, and z, that if we add them up, we get to 360. If we don't, I believe I'm doing something wrong. All right, to find y, I have an inscribed angle of 78, but the central angle would be 2 times bigger, and that central angle is what makes up y. And so I'm going to take 78, I'm going to take y, and that's going to be 78 times 2. And so y is going to be, I got to actually use my calculator again, 78 times 2 is 156 degrees. And then lastly, I have to actually do a couple things here. I know that was 90, I know that was 78, so I actually need to find out what that last angle is. So I'm going to use the Triangle Sum Theorem. There is 180 degrees in a triangle. So we have 180 degrees in a triangle. We have to take away the 78 because that's part of it. We have to take away the 90, and whatever's left is our last angle. And so 180 minus 78 minus 90 leaves me with 12 degrees. And so if I'm looking for, I believe they call it z, my inscribed angle is 12. So my central angle is 2 times bigger, which gives me an angle of 24 degrees. And I believe that is my answer for z. Now, like I said, I should be able to add all these up, and I should get 360 because it makes up a circle. So 180 degrees plus 156 degrees plus 24. And if that gives me 360, I know I did it right. So 180 minus 150, plus 180 plus 156 plus 24 gives me 360 degrees. All right, a little bit longer. I'm actually really happy that I got this done in the time I did. Make sure you look at math notes again today. Again, another great one where it's showing arc length and how your central angle creates the measurement on the outside. That's that idea of arc measure in degrees, and we talked about arc length. We've said that before. And then again, just recapping the idea of central angle and inscribed angle in 10-15. I know they want us to do that with tracing paper, but I couldn't cut this problem out because the idea of inscribed and central angles is so important. If you have any questions on this lesson, I know it was long. I know there's a lot of information in here. Please send me emails. Happy to help you out if you're stuck on this or some problem on the homework.